welcome to the November meeting of the Texarkana Area IT Users Group. We're going to be talking with Justin Jarrett about DNS, how to do troubleshooting mainly with some small business stuff thrown in. So to go over last month, we had a guy named James Taylor who is a wireless developer here in Texarkana. He is working on the Regions building, putting the data center over there, and he also has loads and loads of experience in other parts of the world, including Afghanistan and Colombia. In a third world country, he's probably been there. He probably built at least part of its wireless infrastructure. Anyways, his talk was on building wireless backhauls, covered a couple items such as towers, spectrum acquisition, and navigating government bureaucracy. And we had a pretty good sized house of 28 people. In case you weren't here the last meeting, this is our new set of logos. So, yay. Alright. Upcoming events. We're having our Christmas party this December 8th, so obviously we'll come up a little bit quicker than we're normally used to. The other thing is, I forgot to put it up here, we're going to be having a white elephant Christmas party, so make sure you bring a white elephant gift. If you aren't familiar with it, Google it. It's funny. It can be cool, but it's mostly funny. Question is, do you want to have potluck or catered? You don't have to answer now. Send me an email. Contact at TxkUG.com, and we'll have that email address again up here on the slides. The January meeting is going to be over Apple mobile device management. If you have any large deployment of Macs, iOS devices such as iPads, iPhones, iPods, this is something you're going to want to look into. So definitely come here and see that. So we're going to be doing the elections for the steering committee. I keep wanting to put standing committee, but steering committee. Basically, it's the leadership. There's 7 seats. Everybody is up. I think most of the standing committee is rerunning for their position. So we definitely look forward to having participation from other members, at least in the competition of voting for seats. In order to run, you need to have at least attended 6 or more meetings. Just basically, hey, you show up half the year, great. In this case, have you shown up since September, the first meeting we got back? So there have been about 13, 14 meetings. Make sure you work in an IT or IT related field. It can be development, server administration, network, something related, or you're a student studying one of those fields.
Management doesn't count?
Management does count. I mean, it's working in IT related field. Project management, come on. Your obligations, you need to attend at least 6 meetings a year. You'll need to, as part of the steering committee, meet. Generally, we meet the following week of a meeting, a regular monthly meeting. So you'll talk about different things going on, recommendations, plans, events, things like that. You'll need to, as part of this position, you'll assist in planning events. So for instance, if we have another Nerds Night Out, by the way, sorry about November. Everybody got real busy, and the TC side got really, really busy, so we weren't able to get that set up. But events like Nerds Night Out, the TxK Showcase, like we had with the broadband, where all the different broadband representatives came and showed up. Things like that, you'll help assist in planning. The same thing goes with these meetings here. Participate in other leadership roles. It might be something like helping to maintain the TxkUG website, which by the way, we should have that done by the end of the year. It's there, but we haven't. If you want to preview it, go to dev.txkug.com, okay? But you'll help assist in that and things like that. You'll also help with, again, planning events. If we need somebody to be a pointer, you may be, hey, go out there, direct people towards where we're supposed to go. You might be asked to call vendors. You might be asked to, the last bullet there, you might be asked to help pay for things like pay for web hosting. The web hosting we have is real cheap. The domain's paid through the end of next year, so, and that was only like $20. So you might have to contribute things like that. Let's see. You serve for a year term. There are no limits on the number of terms you can set. One reason why is there's not a whole lot of us. And two is, if you want to keep up with it like the U.S. Senate, good luck. Well, they don't have term limits, but the president does. If you want to keep up like the president, sorry. Good luck. I really don't want to have to do that, and I don't think anyone else does. If you want to make a nomination, or you want to nominate yourself, just send an email to contact@TxkUG.com, or you can send a Facebook message along with the information. You need to include a brief bio of who you're nominating, or if you're nominating yourself, your brief bio, and a headshot, okay? Not that kind of headshot, more like this kind of headshot, okay guys? I know you like to play video games and stuff. Okay, anyways, that's lost on you. I love you guys. The nominations need to be brought in by December 4th. We will not accept any late nominations due to the fact that we've got to basically email everybody, let everybody make their decision. And again, all 7 seats are up, including mine. So I might not be up here next year, who knows. The current standing committee is Chad Bennett, David Dowdle, Joe Regan, myself, Josh Duncanson, Mike Williams, Paul Lovelace, and Randy Radkin. I know Mike is standing down, so he won't be rerunning for that position. I'm not sure about the rest. I will be rerunning. You guys, David, are you gonna? Oh, David doesn't want to rerun again. Okay.
I'm good.
Okay. But definitely encourage you, even if you're running against me, I don't care. Man, we're not running against each other anyways. We're just running for a pool of seats. So we probably will end up needing runoffs of some sort, but we'll get to that when we get there. And our speaker today is the talented Justin Jarrett. He is we've had an interesting relationship over the years. He's been a student worker at Texarkana College, and they kind of disappeared for a little bit, and then he's like, oh, you're working at Zimmerman? Oh, wow, cool. So that is what he's been doing for how many years? He's been over there?
Just one.
Just 1 year? Okay, 1 year before that, I mean, a lot of other things. Datacast. So he has a couple of former co-workers in the room. So anyways, without any further ado, Justin Jarrett.
So DNS is what we're going to be talking about. Not really a DNS expert per se, but I have worked with it quite a bit over the years. Had to troubleshoot a lot of issues. So I've learned some things through troubleshooting issues, and we're going to be going over some of those today. Some tips and tricks that you can use to troubleshoot your own DNS issues. Start off, we'll just kind of go over, start off on a high level. We won't spend too much time there, but DNS is a hierarchical distributed system. It resolves domain names to IP addresses. Most of us know the basics on that. Here's kind of just a full recursive lookup process that we'll walk through real quick. So a lot of us are going to be familiar. We're going to have clients on our LAN. We're going to have our own DNS server on our site, and our clients, for instance, will send a request, say for captivatingtechnology.com, to our local DNS server. Our local DNS server typically is going to be configured to forward that query out to some DNS server on the internet, like Google's OpenDNS, your ISP's DNS servers, whatever you have configured there. So the server will forward that over to the recursive resolver. And here is where a lot of the actual work happens on the recursive resolver outside of our own organizations, outside of our own LANs. So the recursive resolver is going to begin this lookup process by going to the root name servers. Some examples of them there, which you can't really read. The root name servers are not actually going to have the answer to the query. But what they will do is step you down to the next set of name servers that are closer to the ones having the answer. So for example, the root name server here is going to respond, and it's going to give you a list of name servers for the com domain. And so the recursive resolver is going to get those, it's going to pick one from the list, and then it's going to forward that same request over to the com name servers. The com name servers are also not going to have the answer, but what they will know about is the name servers for captivatingtechnology.com. And so they'll reply with those. The recursive resolver will then know about the name servers for captivatingtechnology.com, and it will finally send the query for www to them. They'll respond with that answer, and then the recursive resolver will finally return that answer to your local DNS server, which will pass it back to the client. So a couple of things to note. Obviously, that's a pretty long, drawn-out process, and it's only getting longer with things like DNSSEC becoming more prevalent. It adds a lot of data that has to be passed back and forth to go through this full resolution process. And that's one of the reasons that we use forwarding servers like this and caching servers. If you had to do this full lookup process for every single query, you'd get a lot of DNS timeouts. There'd be a lot more load on the DNS infrastructure. And so it's important to use caching servers and try to make your lookups as efficient as possible. Let's go ahead and move on then. So the syntax of a domain name I have up here. Root is represented by a dot to the far right. It's the name structure is hierarchical. It goes from right to left, so it's kind of backwards. Directly underneath root, those domain names are usually referred to as top-level domain names. The names use dots for delimiters, in addition to representing root on the far right. And then everything underneath that is subdomains. So they're also referred to as children and parents. You can use that to refer to them. So apples would be a child of fruits, fruits would be a child of com, or a subdomain of com. And another thing to note is that the values separated by the delimiters can also be referred to as labels. And you'll see that a lot if you ever go looking through like RFCs and stuff like that. They'll refer to them as labels. So that's the syntax. When you go to troubleshoot a DNS issue, there's a lot of different tools that you can use. I've got some listed here that we can look at. Dig is a Linux utility. It's kind of similar to NSLookup, which probably most of us are familiar with. NSLookup, there's actually a tool named NSLookup, both on Linux and Windows. Bind is actually a full DNS server, but you can also throw it up in a VM. It can be really useful for troubleshooting. For example, on our LAN, most of us, we're obviously going to have clients, and we're going to have a local DNS server that basically just forwards queries out. A lot of times our local DNS server will not go through the full recursive process, but sometimes it's important to see the full recursive lookup process in order to troubleshoot an issue. So if you're ever in that kind of situation, it's really easy to throw up a bind server and run Wireshark on it or something like that in order to basically get a look into the full recursive process. You can also kind of simulate the full recursive process with tools like Dig and NSLookup, because you can actually direct those to query specific servers. So for instance, you could tell Dig to query the root server specifically and just kind of do the recursive lookup yourself manually each step. Routex is a website that I've used a lot in the past. You can look up all kinds of information on Routex. It can also, I think it stores historical information, so you can kind of look into the past a little bit if you need to. Maybe see when a record changed or something like that. MX Toolbox is a great website. A lot of people use it to troubleshoot MX records specifically, but they have a ton of tools on their website. It's not just for MX troubleshooting. VeriSign Labs has a lot of tools as well, including tools that can help you troubleshoot DNS issues. Of course, Wireshark or your favorite packet analyzer is always good to use. It's always good, in addition to learning these tools like Dig and DNS it's always helpful to actually look at the packets that are being sent out from these tools and received back. It's really easy to look into the packets and see the specific information that's being passed back and forth. That can really help with troubleshooting issues. And then, of course, Whois, to look up Whois information for domains. So let's look at some of these tools real quick. Preparing to troubleshoot for DNS issues, it's really good to get familiar with these tools while things are working. So don't wait until you have an issue to try to learn how to use Dig or DNS. Really dig into them while things are working. Get familiar with the way the tools behave. Get familiar with the output from the tools and the kind of output that you get, especially for your own domain names and things. It's going to be a lot easier to troubleshoot and spot issues if you know what's supposed to be there. You wait until you have a DNS issue and then you fire up Dig or DNS and you do a query and you get some information back. If you don't know what's supposed to be there, it's going to be really hard to know what is off or what is wrong in the answer. So let's fire up VirtualBox real quick and take a look at some of these. And another thing to note, some of these tools are on Linux, some of these are on Windows. Just because your computer is a Windows or Linux workstation, that doesn't mean you can't use the other tools. I use tools from both platforms almost every time I troubleshoot a DNS issue. It's really easy to throw up a virtual machine, and I highly recommend it, just so that you have all of the tools available at your disposal. There's really no reason to settle just because you have one platform or another.
Can I run Android on my iPhone?
Can't help you with that one. Just fire up Dig here to start off with and take a look at some of the stuff that we can do with it. Can everybody hear me okay? Am I talking loud enough? All right. Every presenter has to type in a password wrong at least once, right?
Mm-hmm. Or else it's just a pre-recorded demo.
I had the time. So, we'll look this up a little bit. So, if you're just starting off and you want to get familiar with the tools on Dig or on Linux, the best things you can do is jump in the the manual page, and just read through it. Not only read through it, but when you get to some of these options, actually do some queries with these options and just kind of get to know them, get to know their behavior, and see what they do. So really good to get familiar with them. Basically, just like NS lookup, you can just punch in dig and a domain name. It's probably not going to resolve. I have this set up for demo. Just change it real quick. So, kind of see the output dig here. It'll show you quite a bit of information. You've got different flags here. You can always look up what the different flags mean. Those can be important when you're troubleshooting an issue. See, we've got our answer here, who resolves this IP. So that's the very basic usage of dig. But it's a lot more powerful than that. You can actually query specific servers, different record types. So for example, like I mentioned earlier, we could kind of simulate the full recursive lookup process. So we could actually just like dig for root NS servers, and we'll get a list of them there. And then we could pick one out of the list, look up its IP. So we could say k.rootservers.net, and we'll get the IP there. So then we can dig at that server specifically. And we could start our recursive lookup process. So we could say target.captivatingtechnology.com, and like I said, it's not actually going to know the answer to our query, but it will give us a list of name servers for com. So then we could go and pick one of those, do the same thing, and work our way down through the DNS hierarchy until we finally get to the answer to our query. NS lookup on Windows, it's got a help section as well. Definitely read through that. There's a lot of options for that too. And in addition to just doing NS lookup and then say a domain name to look up, you can actually drop down into NS lookup. And here you can set a lot of options. Like you can do server and specify a server to query. You can set type and specify a type of record to look up. So you could do NS, A records, etc. There's a lot of options there. And like I said, definitely pays off to really get to know these tools and how they work. So in addition to the tools, there's also a lot of websites that I have listed here that are great to get familiar with as well. Just pull one up real quick. It's VeriSign Labs. So they've got a lot of tools here on VeriSign Labs. For example, this DNSSEC debugger. It's a great tool to use. You can just punch in a domain name. It gives you a lot of good feedback here. Showing you if DNSSEC is not set up properly, or if it is. Obviously, got all green checks here, so it is. If something is not set up properly, it'll have a red X. It'll give you hints on how to potentially resolve the issue. It'll tell you specifically what's wrong. It won't just say DNSSEC isn't working, but it'll kind of tell you what part of DNSSEC is not working. A lot of great tools. There's obviously more out there, but those are kind of some of the ones that I use the most. Let's see. There's a couple of things I've run into using these tools that you may or may not ever run into. But for instance, within this lookup, does anyone ever say in troubleshooting an issue, you try to ping a host on your LAN, and you try to do an DNS lookup for the host, and one works and one doesn't, and you're wondering why would I be able to do a DNS lookup for the host, or why when I ping it, it resolves, when I do a DNS lookup, it doesn't. So DNS lookup actually does not use Windows System Resolver to do its queries, whereas ping does. And so knowing your tools when you're troubleshooting an issue, really knowing the ins and outs of your tools can make a big difference. Just like in that case, knowing that DNS lookup doesn't use the system resolver can save you a lot of confusion. Let's see. Another thing to keep in mind, especially with like DNS lookup on Windows, a lot of our workstations, they're going to be on a domain, so they're going to have auto suffixes for our DNS, and when we do queries on the command line, it's actually going to automatically append that and try to do a lookup with that. So for instance, you may go in and try to do a lookup for google.com, and you're on corp.domain.com is your domain, and so it actually does a query for google.com.corp.domain.com. And most of the time that's going to fail, and then it'll drop down and do a query for google.com and return you that answer. But I've actually seen some scenarios where it does resolve and you get a totally unexpected IP back. One thing that I would recommend getting in the habit of is when you're doing queries for troubleshooting, specify root on the end. That'll bypass the system automatically adding that suffix on there, and it can save you some confusion and headache. I've even done queries where it automatically appended a suffix and it did resolve, and I didn't realize that it had done that, and I got this weird IP back. I couldn't figure out what was going on. But specifying root is a good habit to get into. So just add a dot to the end of your domain names when you're troubleshooting things. The RFCs are also a good place to go if you're wondering how something should behave. So if you're querying a DNS server and it's behaving a certain way and you're wondering, is it supposed to be doing that? RFCs are going to have the answer. It can be kind of burdensome to find the answer in the RFCs. They can be pretty dull, but I've actually had to do that before, and they are out there. So just keep in mind, RFCs are out there and they will often hold the answer if you're wondering how something should behave. Another thing to keep in mind as far as tools go, you buy a domain name, say from namecheap.com. A lot of us we're just going to use their name servers or wherever you buy it from, GoDaddy, etc. Their web tools, I don't think I've ever found one that wasn't glitchy. So that's definitely something to keep in mind, especially if you deviate from just your basic A records. So for instance, on Namecheap, I tried to add a record that had some special characters in the data. It not only crashed the website, but it actually ended up getting the whole zone removed off of Namecheap's name servers. So another thing to prepare for if you're using one of those websites for DNS hosting, which can be done with off-the-shelf software. It even has a GUI. It's not really hard to do. So that definitely shows the need to be using things like DNSSEC. So we're going to pick our DNS server as a target and our gateway as a target. DNS spoof plugin. And over here on our client machine, we're just going to query that name server for technology.com. And the answer we get back is 10.10.10.10, which is not correct. And we can see on our attacker machine, it saw it come through and it spoofed it. So that is without DNSSEC. That's how easy it is to manipulate DNS traffic on the internet that doesn't have any of these security features enabled. It's just plain text. Very, very easy. And with this particular man-in-the-middle attack, it's just one example of many. There's a lot of different ways to go about attacking it. So to overcome that, it's actually very, very simple. We can just tell our DNS server here, oops. Tell our DNS server to validate DNSSEC information. So set that to auto. Restart it. Now we'll do the same query over again. And the result that we're going to get back is actually a server fail. And the reason for that is the man-in-the-middle machine still attempted to spoof it. You can see here the server was desperately trying to get the record back, but it knows that the record it was getting back from our attacker machine was not correct because of DNSSEC. So a couple of things to note about DNSSEC. Encryption can provide a number of different things. It can provide confidentiality, it can provide non-repudiation, it can provide data integrity. In the case of DNSSEC, it does not provide confidentiality, so it doesn't actually hide the data that's being passed back and forth. It just provides a way to verify that it hasn't been changed in transit. So in this case, the data actually being passed back can still be read on the internet. It's not hidden underneath encryption. And so our man-in-the-middle machine, it was still able to change the record or send back a false record. However, because of DNSSEC, the server was able to know that it was not the correct information. So that's why we got a server fail in this case. So that actually is DNSSEC working because we prevented the target machine from sending back false information. We still weren't able to resolve the name we wanted, but that's certainly better than being redirected to a malicious website or something like that. So that is DNSSEC in action. The next thing we're going to look at is TxkUG in action. So when you have multiple name servers, you're going to have, in this case, a master server and a slave server. And the slave server is going to pull, it's basically going to mirror the records on the master server. You're going to update your records on the master server. They're going to be automatically transferred over to the slave server. The transfer process, again, is old and insecure by default. TxkUG is something that was developed to make it more secure. That again is something that you have to configure. So pretty much by default, if you just threw up a couple of bind servers and started running your DNS on that, if you didn't go in and implement things like TxkUG, you would be vulnerable to some really basic attacks. So in this case, we've got a rogue server on the LAN, and it's going to ARP spoof. Basically, it's going to tell the slave server that it has the IP of the master server, and the slave server will actually accept zone updates from this rogue server. Without TxkUG, it won't know any better. So get those VMs up and going here. Shut this down properly, so I'll need it later.
Yeah.
Yeah, I didn't really have a chance to time this, so I was still preparing these VMs last night, so.
Or practice in front of the crowd.
Yeah. Yeah, it's pretty much up to the wire getting these VMs together, so. All right. So we've got two name servers, NSO3 and NSO4. NSO3 is the master, NSO4 is slave. And to show their configuration here, just update the zone on the master. So we've got our zone file here, and update the serial. It up, and we'll change this here to 7. We're at 4. Look up for that record. And we can see it pulled it over, because that's the record we just updated from 6 to 7. So now we can over here to man the middle machine. Give ourselves the same IP. that master server. Obviously, normally on a LAN, this would be a misconfiguration. Two clients configured with the same IP, they're basically just going to be fighting over it. But with ARP spoofing, we can win that fight pretty easily. So our slave is .40, our master is .30. So we're going to add those to the targets, and we're just going to poison their ARP. And then all we really need is that rogue DNS server setup and our own zone file. We've already got a serial 5, which is higher. Then record here pointing back to us, the target record. And so should accept. Actually, we need to trigger an update. So we're going to increment this again. This was one demo that I didn't have time to test, so let's see if it works or not. Probably the issue here is it's still using the 201 IP instead. Let me be right back. So now it worked. So basically, our slave here accepted zone updates from our man-in-the-middle machine. So we've got that IP there, the .201, that's our attacker machine, and it didn't know any better. It had no TxkUG or anything like that. It's pretty much just all plain text transactions. And obviously that's a huge problem if you've got DNS servers out there in production and they'll accept zone updates from any rogue DNS server out there. And TxkUG will prevent that. So basically, TxkUG is just a way you can configure your masters and your slaves with some keys and basically tell it to only accept zone transfers if they are signed with those keys. So, shut this down. And start over NS, our other NS03 and our other NS04, which are the same server, but just after configuring TxkUG. kind of do the same thing here. Got our zone file on the master, we can increment it up. Change this to 8, just so we know that it got updated. You can reload the zone without restarting mine completely, but it's the easiest way. And so our slave and our master are communicating. And restart our fan in the middle here. So we're basically doing this exact same steps that we just did, which worked. But now our master and our slave have TxkUG configured. Target the master and slave. Change this. So we're giving ourselves the IP of the master. And we've got our So now on our slave, you should be able to see, first of all, that we are not getting the bad zone information from the man in the middle. And we can actually see in the log Should be. Well, at any rate, I don't know if this is going to work or not, but TxkUG is preventing the rogue server from pushing updates to it. And that's basically what I had. So in summary, really the main thing is familiarizing yourself with the tools to be able to prepare now to troubleshoot later. Familiarize yourself with the tools, their output, their behavior, and while things are working properly, you want to get familiar with what you should be able to expect in your query responses. It's going to be a lot easier to be able to pick out where something is wrong if you know what you're expecting. Familiarizing yourself with the query process and the answer process, look at the packet exchanges, and make sure you're looking at it on both sides of the recursive resolver. So again, like I said, a lot of us are going to have our clients, we're going to have a DNS server that forwards queries to another DNS server, and a lot of us are going to be familiar with all of the packet exchanges there, but to troubleshoot a lot of DNS issues, you need to be looking at the recursive process that typically takes place on someone else's DNS server, like your ISP's or Google's. And so you can throw up a recursive resolver in a VM to see that process or whatever you need to do, but being familiar with that process is important to troubleshoot a lot of DNS issues. That's what I got.
This has been a production of the Texarkana Area Information Technology Users Group. We are an industry organization representing IT professionals and business owners in Texarkana, Arkansas and Texarkana, Texas. Texarkana Area Information Technology Users Group meets on the third Friday of each month for an hour of camaraderie, food, and mutual enrichment. Each meeting, a member or vendor presents on an IT topic relevant to our membership. We invite all area IT professionals, students, and stakeholders to participate in these discussions and build personal and professional relationships that add value to you and your organization. If you would like more information, please go to www.facebook.com/TxkUG or visit our website at www.TxkUG.com. Thank you again for watching this presentation by the Texarkana Area Information Technology Users Group.